One of the main things that I like to at least boast about myself is I'm on the code making panel for the National Electric Code for that book that you see right there. I'm on code making panel number 7, actually writes the regulations for the NEC, so I'm involved with those regulations as well. So appreciate that opportunity to be there, and also opportunity to represent ABYC on the code. And there's some representation of ABYC, the American Boat and Yacht Council, here today. Just for the 2026 code cycle, this is where the states are today, or at least within the last couple months. All the tan is under the 2023. Then all the ones that's in red squares are in process of adopting 2023, which will be about half the states in the U.S. The rest of the states are on 2020 or even 2017, like the state of Tennessee is under 2017. So we're not in process of updating, but I'd say in the next year or so we will be updating to 2023. And unlike Kentucky, just the neighbor north of us, they're going from 2017 up to 2023 and skipping the 2022 cycle. So that's part of what we're doing. And just for let you know, where Maffett Loftis, where we work, is almost in every single state, but every circle that you see on that map, we have projects in. So we travel from coast to coast, north to south, and even outside the U.S. in the Bahamas and Virgin Islands, even across the pond. If you want us to go there, we'll be able to have projects out there. Okay, let's get right into this. In 2026, just a little bit of background before we get started. Every 3 years, the code cycle, or that the National Electric Code, the NEC, gets updated every 3 years. So we have 2017, which was what some states are under. We have the 2020 cycle. We have the 2023, which is the latest printed cycle, and we're working on the 2026 right now. Actually, we went through the first revision last year. We had about 4,800 public inputs that we had to go through. And a public input is where someone like yourself can address the code making panels and say, I don't like what you're doing here, or I have another idea about this code. Let's put in, then you can submit a public input. You got to have some substantiation about that public input and tell you why, and tell us why you think that code should change, or a new code, or something should be deleted. But we had about 4,800 public inputs from the industry, from just anybody and everybody that wanted to submit a public input. And we had to sort through those, and that's how we established the next code cycle. So we had about that 4,800 public inputs. We went through all those last year for the first revision, and we did a draft of the 2026 code cycle, what we're going to talk about today. And under code making panel number 7, which deals with Article 555 for marinas, we have about 18 or 19 individuals. I'm just one vote on that panel. And we go through our public inputs and we address those. We all vote, look at pros, cons, and see if we think that they ought to change. And we all vote on it. And we have to have a majority vote to be able to pass something about the 2023 to put it in the 2026 cycle. So we do that process, and we spent about 2 weeks going through that process down in Charleston, and then we send it out to the public, and we let the public comment on them. And we receive all the public comments, which are thousands and thousands of comments on what we're going to do for the 2026 code. And then we all met for about another 2 weeks in San Diego, California, and went through the public comments and went through the second revision for the code. And we all voted on that. We still got to go through a balloted vote, but what I'm going to tell you is not set in stone, but it's pretty close for what the 2026 is going to look like. And I got permission to do this through NFPA, to do this type of a class, as long as I made a statement similar to what I just made. It's not set in stone yet, but it's pretty close. Okay? So don't take what I'm saying is going to be printed in the 2026, but I'm telling you it's pretty close. It's not going to change much from what I'm going to tell you today. Okay? So this is what you got to look for in the future as states start adopting the 2026. And this won't go out to print until about mid next year, 2025, about maybe July or August of 2025 was when the 2026 will actually start getting printed. And they'll go out with a digital copy first, and prints will come out after that. So by that time, it will be there. And a lot of states, right after January 2nd of 2026, they'll be adopting this code. So So if you have multiple, I know some of the bigger marina developers in this class, in this audience, they'll be affected by what's here within probably about a year from now. So that's one reason why the Dock Expo wanted me to do this class on what's coming, just to give you a heads up. But anyway, and what I'm going to do is just go through what things have changed. I'm not going through the entire code, but just things that are going to change from 2023 to 2026. And one thing that we have here is that it should already be there, and inspectors require it, but it wasn't listed in the code that all electrical equipment shall be listed. And for example, the state of Tennessee, we have about 19 third-party laboratories that Tennessee recognizes to list equipment. And what's the most famous one that you know of? UL. Okay, that's one of another 18 third-party laboratories that will test and certify equipment. But that's why we don't say UL listed, it's just listed. And other states has a list and similar to that, but UL is not the only one, but it's one of the biggest ones, been around for a very long time. And I work with UL quite often on different pieces of listings as well. So that's one thing that is required. So I'm going to say this right now. Does everybody know what that is? Do you see those on your marinas? That is an unlisted device. It's not listed. Okay, it's not tested. So if you're using these types of adapters, this is a 30 amp twist lock, goes in a 30 amp twist lock receptacle down to a 20 amp, just standard extension cord plug, prong plug. Okay, those are a code violation to use on a marina. So that is an unlisted. The Y adapters that you see, they're not listed for marinas. Okay, so that's a big deal. That's why I wanted to show this. But this is the first time that we put it in code because we want listed equipment. We want equipment out there tested for the environment that they're in. Because if it's untested, we don't know how it's going to behave. And there's a lot of them doesn't make sense, especially if you go from a 50 amp to a Y30. Have you seen those? Okay, what's the problem with those? You have a 50 amp overcurrent protection going down to two 30 amp receptacles. So you could be pulling 40, 45, 48 amps on a 30 amp number 10 wire, and it's a fire hazard because it's going to overheat at some point and melt down. So those are not listed. So I wanted to bring that up because of this code. This right here is a Marine Co. Yep. That is a Marine Co. adapter right there. Yep. And they sell them, and you probably sell them at your ship stores, right?
So according to the 2026 code, we can't use the 50 to 30 amp adapter.
I'm not saying that. The question is, with this code, and I'll answer your question. The question was, after your state adopts 2026, you can't use these adapters. Okay? I'm saying you shouldn't use them anyway, but the NEC, this NEC, I don't care if it's 2017, 2020, or 1998 code. The NEC stops at the receptacle that this plugs into. That's the only jurisdiction. That's the end part of the jurisdiction. That's a shore power pedestal. So I'm saying that the NEC is saying that all premise wiring up to from the service point from the service equipment all the way down to that shore power receptacle is what the NEC covers. Okay, so NEC does not cover this. It does not cover that. It's not regulated by the NEC. Neither are those Y adapters. But I will say this, that if you have a problem, for example, and I got a picture of this, if you plug this in and you're using an extension cord off of that, that extension cord does not have GFCI protection. And the duplex receptacle right beside it, generally in a shore power pedestal, has the GFCI, the little test and reset buttons. Well, there's a reason, because somebody is out using that extension cord. If somebody got hurt on that and got shocked or hurt, or there's a fire, then who's liable for using an unlisted piece of equipment? Okay, that's the issue. And I'm just warning you. I'm not saying don't use it, use it. I'm just telling you what can happen. So I would recommend not using these, and have a duplex receptacle that is GFCI that you plug instead of plugging it into a 30 amp overcurrent protection. Because what type of cord's plugged into that? It's not a 30 amp cord. It's maybe at best a 14 gauge 15 amp cord that you buy from Home Depot, right? And it may be even an indoor, just 2-wire, with not even having a grounding system on it. I've seen a lot of those on marinas. So your maintenance programs and when you do your dock walk, I would recommend not having these on your marina. This is what I'm saying. Okay, got a lot to talk about. I want to talk about maximum voltage, because this is we changed the code here from 2026 to 2023 to 2026, and we just said they're making us put AC only in. Every time we refer to a voltage, it has to be AC, because now we're getting a lot of DC equipment on docks, especially DC charging systems. So when we say this, we're only referring to an AC system for a maximum of 600 volts. So we're not regulating with this Article 555.5 a DC voltage level. And there's some conflicts there that actually I've been putting in designing some DC fast charging systems out in Lake Tahoe and some other locations. Actually, I got one right now in Michigan that we're putting on a marina. And there's no code in 555 about DC systems. But that's what this is referring to, is 600 volts DC. AC, phase to phase. Now, there's a limit to 600 volts. And in Tennessee, there's no limit. Or Kentucky, there's no limit on voltage, because Tennessee and Kentucky has, in their legislative process, eliminated this requirement in the NEC. So therefore, if you look at here, I can put in medium voltage systems in Tennessee and Kentucky, and I'm doing it. And this is why. I got Carter here. He's on this is a medium voltage wire that was the same picture I have up there. Okay, and I did this last year a little bit on wire methods, but I didn't know if you were here or not. But I wanted to reiterate that because of that requirement. If you don't mind touching that, but I want to just let you feel that in the light, and I don't just pass it around the room while I'm talking. And then the amount of power that I can get through that wire, which I can put around my fingers. Okay, that same amount of power. If you look at that piece of wire, which right here, I'm going to pass this around. That piece of wire right there, which this is a portable power cable, type G. Okay, I can get the same amount of power in that cable that I can do this. Okay, but just not that, but that time over. Okay, so the advantages of using that one wire versus all this other portable power cable, and I'll pass that around. Feel how heavy and
I'm very familiar with
yeah.
this.
And that's a 250 kVA portable power cable. So that one medium voltage cable can do the same amount of power that I have for all this other, and that's at 483 phase, by the way. Okay, so it is massive amount of power that you can put through that one medium voltage cable. So I just want to give you an idea of the...
Why do the other states discourage it?
Because they don't know. The question was that Brian just questioned, why is other states discouraged? Because it's in the NEC, right there. And I'm going to ask this audience and the entire marina industry to put in a public input. Remember I talked about public inputs? You can put in public inputs. And there's a process that you have to go through about doing public inputs. And we put in several public inputs, and there were, like I said, almost 4,800 public inputs for the 2026 code cycle. You won't be able to do it again until the 2029, but I would like to start the process now to be able to put in medium voltage in the code, or eliminate 555.5 and not have an upper limit for medium voltage.
What voltage are you running through the medium voltage cable?
The question is what voltage I'm using. I'll show you some examples just right now, okay? But to be able to help with that, Carter Ashby, stand up and say hi, Carter. But I got his email address there. Send him an email if you want to put in a public input, and he'll give you directions on what to do. Okay? Or you send in, just go ahead and send him an email if you want to do this. And then the process comes when the floor opens up for public inputs, he'll send out you another email with instructions on what to do. And more than that, we'll draft some language to help you put in a public input. Because the more public inputs we get, the better off we are of getting it passed, because there's a lot of interest in it. Okay, so if you're interested in doing that, send Carter an email, and he'll help you go through that process. And he's at our booth, number 340. Is that right? He's here all day long. Come by and see him. If you want to give him a card, then he'll put you on the list to be able to do that. Okay, So I encourage you to do that. And if it's just not this one, but any other public input that you'd like to make, you're welcome to do so. But the question was what voltages I use. Right here is Tennessee, and this is back in June of 2022, a rule was passed that said at that time, the maximum voltage was 1,000 volts in code and went back down to 600. But we allowed more than that, but it does have to be engineered, okay? And I'm not trying to promote myself by any means, but the Tennessee state said, this is something different, something new, and it is a higher voltage. I mean, it's very high voltage, or it's medium voltage in my world. And they want it to be engineered and done right, so it does have to have stamped engineering plans, which is rightly so, I think. But in Tennessee, last year we did 3 medium voltage systems, and we did 7,200 volts single phase in a project in East Tennessee, another one in Middle Tennessee, and we did one here in Middle Tennessee at that voltage, almost at 25 kV. And that cable that I'm passing around is a 25 kV cable. And it's a lot of power we can push through there. And that marina there was about an 800 slip marina. Great big houseboats, lots of power, really long distances away. Kentucky also passed the medium voltage system in the real similar language as what Tennessee. Actually, they modeled the Tennessee law and passed it in Kentucky. I'd like to pass it in multiple states, or really be better off just getting it out of the code. So we could do that. And I'm not saying that you have to, do that. You can go back to the traditional 12240 or 483 phase, but you at least have that option and can look at it, especially if you have large marinas, and especially if you have long distances you got to run, the voltage drop is not an issue at all. Actually, we almost ignore the issue, just like the utility would ignore the issue of voltage drop to some degree. So it's a lot better system to be able to do.
Does did that picture depict cost as well?
Oh,
I see
yep.
one wire compared
It is the question is, what about cost? It is in the right situation, Brian, it's a huge cost savings. Okay, if you look at that, and I don't have the numbers in front of me, but you look at that, you just see the cost savings there. But what you don't see is that small cable that you run for a long distance versus all this other cable that you run for a very long distance. The amount of exposure you have as far as damaging the cable and having to replace a cable in the future, that is much less exposure than all this other really heavy cable, because that is massive weight that you have to support and maintain. And this is a lightweight cable. It's easy to maintain, and actually that cable is much more durable than the portable power cable is. So in the right situation, it will save you a lot of money. You don't want to do this for one dock. That's a 48 slip dock. But if you have a larger marina that's out really far, the medium voltage is by far the best way to go. And I think may even have some pictures here. And in Kentucky, actually I'm doing the biggest power system I've ever done in my life in Kentucky. Right there, it's actually about 16 megawatt system, and it's a 1.6 mile long dock. And this is a very massive dock. And think about 1.6 miles, and about every 40 feet we're putting 200 amps in, every 40 feet along the 1.6 miles. So that's a very much of a candidate, and there's no other way of doing it other than the medium voltage. And matter of fact, that was one of the projects there that actually prompted Kentucky to pass the law for the medium voltage. And this is a project I did in Tennessee. That's the service equipment for a massive marina for 800 slips. Think about money savings, but also the simplicity of it. It's not that much there. Okay. This is the CT, and by the way, we comply with every single code except for Article 555.5, and in Tennessee we have the law legislative that says we can do it. So we're code compliant for a medium voltage system all the way across the entire code, including Article 555.35, which I'm not going to talk about, for the ground fault protection. So that's the medium voltage line. We're doing 3-phase, 24.9 volt kV, 24,900 volts. And doing 100 milliamp GFPE, and it's functioning perfectly, no problem at all at 100 milliamps. And so we're every code that that's in the NEC we're complying by with these medium voltage systems. There is just one conduit going down, That's one dock right there, and that's the medium voltage substation that we're using. Very clean looking. It doesn't look a whole lot different than any other substation, maybe a little bit taller because of medium voltage. We got disconnects that can shut that down for maintenance and for emergency situations. We put a disconnect in the ship store, so if anybody has any issues, they can hit it and shut down the substation on the primary side. It's a very nice system to do, and the substations look fine. So anyway, I'd like for you to put public inputs in and help us, as I'm Maffett Loftis Engineering is going to put a public input. I'm on the code making panel, so I'll be able to speak to it. Okay. Load calculations, and moving on to other codes that have been changed in 2026. We're talking about reduction of non-coincidental loads. And the code making panel realized that there could be some loads that only run at a certain time, and say there's 2 loads out there, but only one runs at a time. We only load it for the heaviest load. For example, one that you are very familiar with, say that you got a air conditioner and a heater. Okay? You don't run both of those at the same time. You only run air conditioning or you run the heater. But the circuit going to it has to be supplied for the heaviest load, which is generally the heating, right? Especially if it's resistive heat. But we don't load as far as that circuit, it doesn't have to support the compressor load and the heating strip at the same time, right? So we only do it for the heavier load. Well, it's the same in marinas. For example, what we're saying is that if the boat lift has more power than the shore power, that's a 130 amp short twist lock, then we only have to load that circuit going to it, which powers that boat lift for the heaviest load. That's all we got to do. We don't do the boat lift load and the shore power load together because it don't cost a lot of money to do both because it's a bigger wire. So when I do a load study, I would look at all these loads and just load that circuit down for the heaviest load, especially, and we were thinking boat lifts because we realize that typically you're not going to have somebody on board running hot water, using the galley and air conditioning while you're raising your boat up and down. But sometimes these are 45-ton lifts for boats. So it's just, we're trying to save money as much as we can. So that's a good thing. Yes, ma'am.
What's the price difference between the MV cable and the...
The questions here back on the MV cable. I don't know the exact, but it is very. What the question was is what's the price difference between the MV cable and the G cable? To answer the question, I would say price per foot. Those are about the same. One of these versus that. But you got to get 8 of these to match the same amount of power here. So it could be 8 times less in order of magnitude. Does that help? Okay. Sure. Here, Carter, take that back. Well, I'm getting a lot of interest. That's fine. That's a great question. So I'm stepping it down right there on the dock. Okay. It's 12240 on the secondary side. So I got a step down transformer from this one being 24,900 volts down to 12240.
Still got to carry the wire size from there
to the pedestal. Yes. Yeah, we do. Yeah. But that's no matter what you do, if you got 480 coming down, but not only that, if you go back here, I got a medium voltage one there, and guess what? I got another medium voltage way back over there. So I don't have to carry the lower voltage all the way back. That's where you're saving a lot of money. And think about the amount of wire that you have to through that dock structure to get all the way back over there. You're running one cable that big, or maybe 3 that big, and if you do 3-phase, generally I do single phase. So Tom, does that answer your question and see the benefit now?
Yes, sir.
Okay. Okay, and this code says that for load calculations, for the reduction of non-coincidental loads, also power control systems, and that's something new. Most people, raise your hand if you know what a power control system is. Okay, power control system. What that does is it does exactly what it says. It controls power. Okay, and especially if EVs start coming around a lot, this is going to be a big deal. Especially if you got a fleet of electric vessels in your marina, this is going to be a huge deal. And I got an example of what this could be, say charging electric boats. Of course, you can do fast charge, but you can do fast charge and medium charge, but these solid state load control systems. And I got a graphic here from Purple, this Atom Purple. And what we can do, we can have we can have 400 amps coming into this switchgear. And this switchgear is not your typical switchgear. It's a motor control system. And we can have 400 amps coming in, and that's what they rate this is. The incoming bus is 400 amps. But you can connect up to 12 100 amp breakers to this and supply 1,200 amps worth of load, but it distributes the 400 amps evenly if you want it, or you can have priorities. You can have 4 boats or 3 boats, whatever it may be, that gets 400 amps. And say you're charging boats, you can have priority 1 boats, priority 2 boats, or priority 3 boats. And when a priority 1 boat comes in that pays more money because he's a priority 1, he gets as much power as he wants out of that 400 amps. And then when a priority 2 boat comes in, well, he doesn't get any power until the priority 1 boat gets charged. And you can program these solid state to be able to control that power coming in and which circuit it actually goes out to. And it can be even a revenue income, because you could sell priority 1 slots, priority 2, and priority 3 to your fleet. Unless it's your own fleet, then you can do what you want to, but it regulates that power for you. So what the one benefit as far as cost savings is, you don't have to have a 1200 amp wire, 1200 amp service, you only have a 400 amp service to supply 1200 amps worth of power and distribute it in that fashion. So that's what we're talking about as far as doing the load study. You can have a lot more connected load, even though the NEC would require you in normal circumstances to have 1200 amps worth of switchgear, but now you only have 400 amps worth of switchgear. So that can be a big cost savings, and even actually be a revenue process for you if you're wanting to look in that fashion to do electric charging boats. And actually, I've designed some systems with this. I'm talking with Adam about it. Okay, this is another system another design. This is new about engineering design. And this is a precedent set in other codes as well that actually got brought over by some other code-making panels as well. And for example, NP 303 requires engineering systems as well, but there's also other locations for it. But what we're saying is that we're not saying that all marinas have to be designed. We're just saying that if a electrical inspector requires it or asks for it, you have to supply the engineering plans, is what that's for. But it's only if they ask for it. And what we're thinking is that if there's a problem or it's a very large system, then the HJ may require you to have engineering plans for it. But we even take into account that engineering plans are not required for like a 1 or 2 family dwelling. If it's only 1 dock or 3 slips, then it's not going to be an issue. We're not saying that the inspector, you can't ask for a plan for very small systems. But that is going to be in the code as well. And that's just for little small docks like that and other places. But okay, 555.13 is another location that we've changed some code language. And this is actually in 2023, and I wanted to compare 2023, I'm probably in your way, but compare 2023 to 2026, because this is a huge change for what we had in 2023. What here is, there's a list of 3 pieces of metal. Says all metal parts in contact with the water, comma, all metal piping and non-current carrying metal parts. And that non-current metal parts could be anything that you could touch. It could be a spud pole metal, it could be the dock structure itself, it could be whatever it may be. Maybe some sort of handrail, aluminum handrail. But we got list those 3 different pieces. But the issue is, and this was probably some language issues, it was not the intent from the code-making panel, but it says that all these 3 that's likely to be energized, and that likely to be energized by interpretation from some electrical inspectors is only for that 3rd piece of metal. Okay? And the issue is that it says, and they're saying that likely to be energized only applies to that 3rd item and does not apply for the previous 2. So what they're saying is that any metal that's in contact with water has to be bonded to the grounding bus of a panel board. And that's a problem, because if you think about, if you got metal spud poles, how do you bond a metal spud pole? It's in contact with the water. And that's my argument. Okay? There's a lot of dock manufacturers that little metal gusset plates in the corner sometimes. Okay? And they're in contact with the water. They're not likely to be energized. There's no conduit, no wiring anywhere close. We even have an inspector down in South Florida on the West Coast on timber frame docks, and the cross bracings underneath the timber frame docks. What are they bolted to the spud poles with? The pilings. Through boats, which are metal. He's saying that all those metal bolts that is in contact with water has to be bonded back to the panel.
Every winch stand is continuous.
Yes, okay. So every piece of metal that's in contact with the water, they're making them bond it down in Florida. Because of this, because they're reading this, that likely to be energized is only applying to that third piece of metal. That was not the intent of the code making panel when this was written. The intent was that any piece of metal that's likely to be energized shall be bonded. And that's what it needs to be, because if you have, say, a galvanized truss frame on a freshwater lake and you're running electrical conduits through it, well, at some point during a storm damage or just wear and tear, that dock's structure could be likely to be energized by that electrical conduits and that electrical wire. That galvanized truss system needs to be bonded because it's likely to be energized. But a spud pole that is way away, or if you got a spud pole in the end of a finger, there's no electrical conduits around that at all. It's not likely to be energized. But some inspectors are saying it has to be because it's in the 2023 code like that. So in 2026, I've submitted a public comment. And by the way, that's, if you can't see it from over here, but that says a solid wire. Okay. Solid wire as a demand from the code making panel should not be anywhere on a marina. Okay. You're allowed to put solid wire, but it should not be a command from the NEC to put a solid wire, especially on a floating dock. Okay. You need flexibility as much as you possibly can on a floating dock, going through fifth wheels, hinge points, down gangway ramps. You got to have flexibility. So but where this came across was from Article 680, which was swimming pools. And that's the language that they had, and there's the correlation committee was trying to make the safety requirements in a marina and in a swimming pool the same safety requirements at a marina. Two different individuals. There's no way that worked. So that's where that convoluted language came from. So in 2026, this is what we're saying. Up there at 2026, we're just saying all non-current metal parts has to be bonded. All that's likely to be energized, period. If it's likely to be energized, then we bond it. And for you electricians out there, you understand what bonding means. That's just connecting the wire back to a grounding point. But the 2026 has said that number 8, solid wire, had to go back to a panel board. We're not saying that. We're saying it's going back to the grounding equipment conductor, which is really close in many instances. Okay? And the purpose of this is not to create fault current. That means if you have a 50 amp overcurrent protection, it has to pull at least 50 amps to trip that overcurrent protection. We're just trying to bond it to be able to create enough current flow if it did get energized to trip the GFPE, which is about 100 milliamps. That's the only thing we're trying to do. So therefore, what we're saying to do, it doesn't have to be any larger than the number 8 wire, which is a smaller wire, and there'd be a lot less than that. For example, if it's a lighting circuit with a 12 gauge wire, then the bonding wire can only be 12 gauge. Okay, it makes sense because that's definitely enough to pull 100 milliamps to be able to trip the overcurrent protection. So this is another big money saver that I submitted a public input, and the code making panel said, sure, that makes a lot of sense. So that's what we did. Okay. And this was not mine, but this is an equal potential plane. Actually, it's in the 2023 as well. We kind of revamped it a little bit. We couldn't get it taken out, but it is what it is. There's some regulations there that I don't think a lot of people will have to do this, but it's an equal potential plane, and that's a big term, but equal potential, equal is just the same, okay? Potential is voltage, and a plane is anything that you can touch, okay? I don't care if it's a railing on a boat or you have a railing down a handrail. Anything that you can touch, that a human being can touch, is the plane. And we want everything equal. So there's no current flow between that piece of metal and this piece of metal. Because if you have a difference in potential or a difference in voltage and a human being touches those two pieces that are different voltage, you don't have current flow through your body. So that's a very important term, especially in the marina industry, is this equal potential plane. And that's what we want everywhere as much as practical. But what we're saying is that we want that equal potential plane that extends in the basically the following conditions. If the system voltage exceeds 250 volts, which basically is a 483 phase system. If it's a standard 122 40 volt system, you don't have to worry about the equal potential plane. And we didn't want to be overbearing with this code, so that's there. But anywhere that within 3 feet of that piece of service equipment has to have that equal potential plane. I'll show you a graphic of that. But if you have a upland piece of gear that's 43 phase, 3 feet away from it has to be this plane. And there's different things about it. It's not encompassed the entire area, 36 inches out. And if you think about this piece of service equipment right there, and we got several different types of medium around that. We got concrete, got gravel, earth underneath that gravel. But what we're saying is, if it's within 10 feet of the water, and that's what that one of those regulations said, it has to have this equal potential plane. And that plane would be a distance around 3 feet all the way around that piece of equipment. The trick is just don't put your piece of equipment 3 feet, 10 feet from the water, and you don't have to do any of this, okay? But in this case, if it's in concrete, the rebar that's in that concrete would have to be bonded back to the grounding bus. If it's gravel or grass, then you got to create a grid of either copper grid or a rebar grid that's out there buried in the earth, and bond all that back up to the panel. So anywhere 3 feet all the way around them, all 4 sides has to be that equal potential plane if that equipment's within 10 feet of the water. So just don't put your equipment within 10 feet of the water and don't have to worry about it. Okay? Yes? Say a little louder. No, that's a good question. Okay? If you do this next code, let's see. Where was that? Right there. I thought that was here. Structural reinforce. Okay. Well, that's still. I got a slide about that. This is just talking about if you talking about how to do it. Rebar and concrete and other copper grid. That's what I was talking about. I'll get to your question just in a moment. But this is on land. If it's that's that copper grid. That's if it's in grass or in gravel. I have to be on 12-inch centers. And here, area is not required to have this equal potential plane. If it's on the docking facility, on a floating building, you don't have to have this out on the marina. Because it's a lot of times it's a concrete deck, wood deck, timber deck, a galvanized truss system or aluminum truss system. And if it's a galvanized metal truss system, it's going to be bonded anyway. And you already automatically have that equal potential plane out on the marina. But we're saying we're limited only on the land areas. So does that answer your question? Okay. So that's already in the code, and that's part B of that same code. So if you have subpanels out on the question was if you had subpanels, electrical equipment, substations, whatever it may be, out on the dock, do you have to do this equal potential plane? And the answer is no, but you still have to bond the metal that's likely to be energized, which creates that equal potential plane. So that was in that Article 555.13. Okay, here's another code that it's new, that if you have a shore power at a slip, okay, in 2026, it's going to require you to put in a 20 amp GFCI receptacle as well, which makes sense to do it. And what that does is eliminates, for example, if you only have a double 30 amps at your pedestal level and do not have a 20 amp, if they want a plug an extension cord in, this is what they got to use to plug it in here. Okay, so that was to help eliminate using these unlisted pieces of adapters, is what that was for. So if you have if you just, and this just had, which you can get this, Eric, you're in here, right? You can order this without that, correct? The 20 amp, and just to be a blank there. Okay, you can't order it like that, but in 2026 they'll have to have it. So you'll have to have that 20 amp for not for shore power sitting there at the GFCI. That will be a requirement in 2026. Okay. This is really not new, but it's worded a little bit different about branch circuits and feeders. We had a little bit of a holes in the ground fault protection. There was some circuits that was not required under the 2023 to be have 100 milliamp GFPE. So we kind of fixed that by saying the branch circuits, not more, because you could have a some lighting on a little party deck or a gazebo out on your marina. And that lighting circuit was not required under 2023 to have GFPE on it. And this language fits that. However, there are exceptions of some wire on a marina that is not required to have GFPE. And what that is if it's a separate drive system, and a transformer is a separate drive system. And the secondary wires from a transformer out to the panel does not have to have GFPE on it, because it's really hard to put 100 milliamp GFPE in the secondary side of a transformer. You just can't do it. And 2023 actually said transformer, but we changed it to this separate drive system, and that could be an inverter. I know some of the SunTech projects, we're having to put emergency lighting because Kentucky is requiring us to put emergency lighting on covered docks. Well, we're putting this battery backup inverter system on it that doesn't have GFPE. So that's been an issue for me as an engineer for SunTech about what do I do from that wire from there to the panel where I can put GFPE in the panel, but I can't put it in the inverter. So that inverter is a separate drive system because it's driving its power when the normal power's off. It's generating from battery, converting that to 120 volt AC that we can power emergency lights with. So what I'm saying is that separate drive system, as long as that wire is less than 10 feet and installed in a raceway, a piece of conduit, then it does not have to have GFPE, which solves a lot of air problems, Adam, with those systems that we have. And it can be installed without GFPE. Think about a generator. It's a separate drive system. And if you have a generator, which I've been installing some generators or designing generators on out on the floating dock, from the generator to the first point of overcurrent protection doesn't have to have GFPE because the manufacturers and Generac, can you get GFPE? And I don't know if you can get GFPE or not in a Generac, which there's a booth out there with E&W about Generac generators, but it's very difficult, like pulling teeth, to get them to put GFPE in it. But as long as that wire is less than 10 feet and it's on a raceway, we can get to a panel. So those are the types of systems I'm talking about. And fire pumps. Does anybody have a fire pump on their dock? Nobody? They're getting to be more and more. We've done several here recently with fire pumps. Well, fire pump is there for life safety, right? And we're doing some electric fire pumps, some diesel fire pumps. But the circuit, I don't want to have GFPE on it. But Article 555.Pren A says you have to have GFPE on a fire pump because it's a feeder. Well, I don't want a GFPE on it because if it trips, we don't have a fire pump. And it's a very important thing to have a fire pump. So what we're saying is, for fire pumps, we can use a ground fault monitoring system, monitor for leakage currents, and if it reaches above that 100 milliamp, then it will notify with audible and visible alarms. That you can go out there, you can shut it down temporarily, fix the issue that's causing the leakage current, then power it back up, and then you got a fire pump without leakage current again.
Fire pump runs when there's a fire, and the code states that is not allowed to shut off. In Chicago, you're wired right to the power company.
Absolutely.
Right.
There's no overcurrent protection.
GFI cannot shut that off.
No. And that's exactly what I'm saying. Yeah. And actually,
And as far as an audible and the visual, you're not going to be in the building when that pump's running anyway.
well, that's the best alternative that we could come up with. If you got something else, put it in a public input, and we'll take a look at it. But
You understand?
yeah, I understand.
It goes right to the power company.
Yep.
You can't disconnect it.
Well, we have to put a disconnect. It can be a relay, or you can put overcurrent protection in under the code, but the overcurrent protection size has to be the locked rotor amps of the fire pump. And that's what we do. If the locked rotor amps is 600 amps, we put a 600 amp shunt trip breaker in, monitor the circuit, and then actually it's not even shunt trip. Just put a 600 amp breaker in, or it could be unfused inductors all the way down. I've done it both ways.
And then how are you putting DC fire alarms and smoke detectors in these marinas? That's DC.
Yeah, we're not. We're not. No, because it's a manual system. Yeah, it's not an automatic sprinkler system. What the question was is how you put in smoke detection. Basically, what your question is, how are we initiating the fire pump? It's not. It's a manual-driven fire pump, and most jurisdictions require us to put the manual switch at the beginning of the entrance of the marina, so they don't have to go out on the marina to turn it on. And what it does, that pump then energizes the dry standpipes on the marina, so they can turn it on. The first responders can turn that fire pump on. It sucks water out of the lake, energizes the dry standpipes. Then the fireman runs down with their hose with the dry standpipes energized, hooked to the 2.5 inch threaded dry standpipe, and then fight a fire from there. What's that? It's a dry hydrant. Yes, it's not an energized hydrant, and they're only energized when somebody turns that fire pump on. So the question was, these systems that we're designing, and we have designed wet systems because the jurisdiction required the wet systems, but most of these with these types of fire pumps will be a dry type system with dry standpipes, and only energized when the fire pump gets turned on. But we do not want to have anything to be able to trip it, so therefore the code making panel said that we have to monitor those circuits because we don't want to have a GFPE that actually trips the circuit. Okay? Especially in the northern states, they take all the boats out. But that's not everywhere in the state, so we got to have some sort of a universal type system. Okay. Also, 525.pren.e, 525.35.pren.e says that you have to have GFPE protection, and it shall be coordinated. And this is a big deal because GFPE has always been a headache, and I've taught a lot about ground fault protections. The 2023 says that GFPE, the coordination would be permitted, but in 2023 says it was permitted. 2026, we're going to require it because there's been a lot of problems with GFPE systems out there, and one bad boat tripping out the entire dock is not acceptable. Okay, it's not acceptable, and I'll show you every marina that I design. I go out and I test, and I make sure that it is coordinated, so that there's not an issue with the GFPE systems. There's still an issue because you can still trip a boat local, but if a bad boat comes in and it wants to leak current, we only want that one receptacle to go dead that's flying power to that boat. We don't want the neighbors to go dead, the 10 boats to go dead, or the entire dock or the entire marina to go dead because you got one bad boat. So therefore, this coordination is very important. And what I mean by that is this. Let me just go through this real quick. Minimum, you'd have to have 100 milliamp up on the shore protecting that feeder, which protects all the other wiring. But at the boat, we have to have 30 milliamp. So we want those two devices or other GFP devices to be coordinated so that if a bad boat gets plugged in here, it only trips that one boat, it does not trip up there. For example, in this example, say a boat comes in, plugs it in, turns the breaker on, and his inverter is leaking 300 milliamps of current. What's going to trip? Is it going to trip there at 30 milliamps, or is it going to trip at the 100 milliamps? If the boat's leaking 300 milliamps, it has opportunity to trip at both locations, right? So therefore, if it's not coordinated, it might trip up here and your entire marina goes down for one bad boat. If that happens, which boat is it? Okay, you go back out and you reset this, turn it back on, and it works for another hour. Then it trips again. What boat was it? You don't know. That's where this gets disabled because the marina wants power. And that happens more than you think. Okay? Because this coordination is a very important thing. If you go back and look, well, there's two ways to coordinate. One is the trip sensitivity levels at 30 and 50, but that doesn't always work because you can have boats that leak more current. But also there's trip delay times. And for example, what I mean by that is, say that I got a lot of GFPEs in here for full coordination, and I got 30 milliamp, 50 milliamp, 75, and 100 at those locations. I'm very limited in time, so I'm going to try to get through this. But if you set the times here, like something I have on the screen, and a bad boat that comes in that leaks 300 milliamps, where is it going to trip now? It's going to trip at the fastest time that you have, right? Because at 75 milliseconds, that bad boat's going to lose its power. What happens when that boat loses its power? It's going to stop leaking current, right? So the next fastest time it ever reaches that time, even though it's 300 milliamps, it's never going to trip that next GFPE level, right? So therefore, only that one boat gets tripped, and that's fully coordinated. Okay, very simple concept, not as easy to implement and design, but it's a very simple concept, and it's very doable. Every single marina that I design is fully coordinated, and then I go out and I test it to make sure that it's coordinated with this type of equipment that I have here. And there's some equipment that has the transformers and the monitors and the panels, and this was at, what marina was this that you wired, Chris? Huh? Twin Creeks Marina. So this is, Chris has a booth out here, so go see him, but he's the one that wired this, Doc. Very neat system. You can also incorporate all this into one substation. There's manufacturers that builds equipment like this that instead of having individual, and it depends on your taste, and lead time is a big deal. So some substations are a lot longer, and in this case we did individual, but it wound up looking a really neat looking installation, and is able to do that full coordination with this. There's the bender unit, there's the CTs inside the cabinets, it's all there. Okay, not only shall it be coordinated, it shall be performance tested. Because the code making panel deems that that is extremely important as far as performance testing. And that's taken from other places than code. And that's what this right here is. I go through with 50 amps, 30 amp, every GFPE point I will test. And I'll test this, and I'll ramp the leakage current up to see where it trips and make sure it trips between my specified time and the code. And also test the timings of all those 30 milliamps and see how fast it is throughout the entire marina, or slow, one of the two. And then I go upstream from there and I set the upstream so it's coordinated with the downstream, so if a bad boat comes in, it's only going to trip locally at that one boat and never trip upstream. So the only thing we're trying to protect with those 100 milliamps is your electrical wiring system. We're not trying to protect the boat with that 100 milliamp. The 30 milliamp is what protects the boat. But if a boat comes in, leaks 500 milliamps, we only want it to trip there, not at your 100 milliamp that's protecting your wiring methods and your equipment from leaking current. Yes, Brian?
Let's say I don't really care for you. Who else do I get to do performance testing?
Well, it says installed on site, this shall testing be provided by a qualified person.
Licensed electrician can do that?
If he knows what he's doing.
Okay.
Yep. And I put that in. I didn't want to say by an engineer there. Okay. And I'm not trying to be self-serving about this at all. But we are set up for it, and if it's my design, I've been requiring this for years now as far as performance testing on systems. Yes, sir, Adam. I would say, the question is, would the electrical inspector be able to do this? I would say absolutely not. Okay, he will not take that liability. Yep.
Is he even going to know to ask for the test?
He will when this comes out in code, yeah. And and none of that, it requires a written report to the AHJ, which is the electrical inspector, for that performance testing.
So as a marina developer or builder, I'm going to need to make sure I buy the performance test
Up front.
when I do one.
Yep, exactly. Yep. The question was that he just needs to make sure that you contract with somebody up front so you know what that cost is to do that performance testing. Which, Brian, when I give you a quote, I always have performance testing in my quote, and I'll tell you how much it is. So I'm right up front with it. And there's me with my cart. This is a project down, it's a saltwater marina down in the panhandle somewhere, but I got several guys, myself, plus others that can go out and do the performance testing. And again, every single GFPE point is tested. And I don't have time to go through this, but some of the things I find in marinas, even though it's already been passed by the electrical inspector, the green wire never should go into that CT where it measures the current. Here I could leak whatever current I wanted and it would never trip, ever. And the inspector passed this. This was a problem at a marina, and the electrician tried to actually cut some corners and wired, and this was my design, but these are GFPE breakers, tried to wire these up with sharing neutrals on GFPE breakers. You can never share a neutral on a GFPE breaker. But this is what he did right there, and I found it, and instead of, if you can't see it over here because that speaker, but if you look around, you can see the wires, they're not terminated on the neutral conductor. He cut off the cut and wired around the GFPE device. Brand new installation. And without the performance, and this was already inspected. The inspector did not see this because it's buried. But when I do the performance testing, I find things like that because it doesn't work correctly. So that's the reason why we're doing performance testing. Here's one with the neutral not in the CT. Okay, that did not work well because every night it'd trip because the photocell on the lights would come on, put neutral currents on the neutral wire, which was outside, and it'd trip. And every morning the contractor would have to come back in and turn the breakers on. And he asked me, why are they tripping every night? You got something wrong here. I said, no, I think you probably don't have the neutral in the CT. You opened it up, sure enough, the neutral wasn't in the CT. This was a manufacturing issue. We got the CT, we got breaker 1, CT 1, which monitors, and then this supposed to go down and trip that breaker, that vendor unit, when there's more than 100 milliamps. Well, when I started ramping up to 100 milliamps, I heard something click, which sounded like a breaker, but I was still able to, the circuit was still energized. So I could leak up to 200 some odd milliamps after it already tripped. What happened, it did not trip breaker 1, but tripped breaker 2, and would not de-energize my circuit. So if I was being electrocuted on the circuit on breaker 1 and leaking 100 milliamps or more, my circuit would never get de-energized. And actually there's fatalities because of this right now, because of that miswire. And sometimes it's manufacturing issues, and sometimes it can be contractor issues. And I found both. And you can see how much leakage current I was leaking, even at 272 milliamps, and it would never trip. So I find stuff like that all the time. There's all kinds of, here's 40% of the breakers didn't work. That's not an issue, that's not a good deal. Here's another one that GFP circuit wouldn't work. All kinds of, this was an issue that they disabled the GFPE. They actually took the shunt trip breakers out so it wouldn't trip all the time because it wasn't fully coordinated and it was such a nuisance, couldn't keep power on. So they disabled the shunt trip breakers. Find all kinds of wire nut issues on the controls because if it's not working correctly, I find those. Issue after issue. Some circuits not wired. Here's a grounding issue on a transformer. This is another one that had swap input outputs. And look at this GFPE device there. That is a GFPE device with a shunt trip breaker. But what is the maximum level? I've been saying on a feeder, how many milliamps? 100 milliamps, okay? If you look at this, look at that ground fault monitoring system, there it is, that's the setting. Does that anywhere close to the 100 milliamps? No, the minimum is 40 amps. That's 40,000 milliamps, not even close to what we needed. This was passed by the HJ. Right on the door, right on the side of it, has an approved sticker it has a signature on it from an electrical inspector. That was an issue of an untrained inspector. He saw a ground fault, oh, that's good, I'm gonna pass it. Okay, this wouldn't protect anything. So, let's see, there's all kinds of other stuff. What do I want to do? Well, is my time up? Unfortunately. Okay. Well, thank you very much. Appreciate you being here. But that's what you got to look forward to for the 2026 cycle.